Hello, everyone. I'd like to take you through the process I used to make some desk art for a coworker of mine named Jen. She's from Canada, and Canada Day was right around the corner, so I thought it would be appropriate to make her a maple leaf. And I'll be cutting this out of steel plate, 0.150 inches thick, a little thicker than an eighth of an inch. And so this desk art is about 11 inches tall, I think about 8 inches wide. And it has a little 5-inch diameter circular base. I'll be welding it together and I'll be painting it red. So here you see me in ViaCAD, which is a CAD program I use to generate a DXF file. And I won't take you through drawing the whole part. You just see the finished drawing here. But I drew half of it and used a mirroring function to get the symmetry. So part's perfectly symmetrical. I drew half of it, mirrored it, and ViaCAD is very inexpensive. I think I paid $100 for this version of ViaCAD 2D. And then you can generate a drawing in minutes. Now you can output all kinds of different drawing types. I use specifically a DXF file. I export a DXF file into SheetCam, which is my CAM program. SheetCam is another inexpensive program. I think I paid $150 for this version of SheetCam, and it has free updates for life, and it's just an unbelievable program for CNC plasma tables. It's practically ideal. So you can get software for a CNC plasma table for not very much money. I think I had $250 in for all my software for my CNC plasma table. But you import the drawing into SheetCam, and SheetCam auto-populates all the parameters needed for the plasma table: the pierce height, the cut height, the pierce delay, the torch offset or the kerf width as it's known, torch speed, torch direction, all the parameters for that. It's all set in, and you initially manually program all these parameters in. And you develop a cut profile for 1/4 inch plate, a 3/16 thick plate, 1/2 inch thick plate. You'll enter in the torch speed, pierce height, and cut height, and pierce delay, and kerf width. All those parameters you'll set in for a certain type of steel plate that you're going to cut, or aluminum plate, anything that's conductive, metal that's metallic and conductive, electrically conductive, you can cut on a CNC plasma table. And so you'll set all here's a shot of all the parameters, lead ins and lead outs and offsets and all these things I have programmed in. And it's just very fast. You can draw a part and have the program ready in 5 to 10 minutes, sometimes faster, as you get more practice and get more adept at using these programs. But I'm just using it on a small laptop here, my kitchen table. It's where I do most of my the CNC work. And then I use a post-processor. A post-processor sets the parameters for your specific table. And they had the Masso control they helped create a post processor for that particular machine I built. And here's a shot of the G code, the raw code itself. And G code actually is pretty simple. And I think years ago, as an exercise in a class, we actually had to write the G code out, and it's not as hard as you would think. It's pretty formulaic by definition, literally. So here's my Masso control. It shows my shape. I just took a USB, a little thumb drive, out to my table in my garage and set this up. And you can, the Masso software is very flexible too. There's a lot of different things you can do with it. And I'm just checking some of the code. And here it is setting up the cut. You can see the surplus saw blade I'm cutting this out of. You can see the torch come down and touch off. The torch actually presses into the material, touches it, hits that little red switch, actually comes up, and then sends a signal to the machine. It's called a torch touch off, and it lets the machine know the height of the material. It does that every time it pierces, and it sets the height of the material and retracts a certain distance. You'll see the part just drop right out here. And my cut speed was pretty good. Now, the amperage of the machine and the cut speed and the cut height, they're all very critical in plasma cutting. If you have one of those parameters off, it creates a very thick edge dross, very thick little buildup on the edge. But if you get those parameters just right, your edges come out perfect. You have a good edge perpendicularity. It's not heavily angled. There's no dross, and I got my cut speeds and height here almost perfect. There was just a little bit of dross, but cleans up really fast with the flap disc here. And this blade had actually been sitting outside for quite a few months here in Washington State. We had one of the wettest months here coming into summer. It's record rainfall here in Washington in 2022. I think we eclipsed the previous record by a significant amount of rainfall in inches this month. So this part had been sitting out in the rain, had quite a bit of corrosion, but it cleaned up really fast with the flap disc. And I'm just removing the corrosion. I'm not putting any type of special finish on it or getting it polished or anything. I'm just removing the corrosion. I'm going to paint this part. Came out really good. Edges are perfect. So here I am cutting out the circular base. It's 5-inch diameter, and this is already a program. I have all these different circle sizes already programmed in my machine. So at the machine, I don't have to draw these in CAD. I can just select these circles on the machine. I have them in all these different diameters, so it's really quick. Cut this base out. I'll clean this up with my flap disc as well. A little more dross on this than there was on the first part. The speed wasn't quite ideal. Now, I could have just welded this together and you would have seen a bead here at the base of this part. But I took a little extra step and I machined a little groove all the way through this part, a little slot. And the maple leaf is going to sit through that part, and I'm going to do a rosette weld on the back side, and you won't see any weld visible at the base. And you can try and, when you're welding around the base of like that, if you're not careful, it easily distorts and pulls the part. You can do some tack welds. You can use a TIG weld process. I have a TIG welder as well, and I can do some very fine welding with that TIG welder. It has a pulse function, but you'd still see the weld bead. So this way, I've cut the slot. I'm going to put the maple leaf in this slot. I'll weld through the back side of it, and then I'll grind it back flush. So you won't see any visible weld. As it sits on the desk and you're looking at the part, you won't see any weld. So these shots aren't very good. They're through my helmet, but you can see me out. I will initially just do one tack just to make sure, and then I check and make sure it hasn't moved, and then I'll actually kind of run a bead across here. And then I got good penetration on this. It's a very strong weld, actually. People have different names for them. I call them a rosette weld. And a lot of rosette welds are actually circular. You drill a hole, and then you weld through that hole into a part underneath it, usually. But this type of welding, I just call it rosette welding. But you can see there's a little bit of heat affected zone. I got good penetration on this. I had the welder set properly for the thickness of the material. But this is perfect for not distorting the part as you weld it. You can see I ground this back flush. There's really no evidence of the weld. So it's very strong, and the base looks very clean. You don't see a huge bead around it and much struggling with the distortion and everything associated with that. So now you see I'm just throwing some red paint on this. I did clean this part. I did wipe it down with some acetone. I got some acetone and cleaned that up, especially after the welding and handling it. And so I did a pretty good clean. And then I just gave it some couple light coats of this red. This is the idyllic maple leaf color. And so here's the finished part. Came out really good in my opinion. The color came out perfect. The edges came out perfect. I had good adhesion. I cleaned this part, prepped it properly. And you can really see the base there is a very clean look. Now, you can't see a bead around the base. It's all on the underside. It's very clean. And so kind of take the extra time sometimes and make something turn out really nice. I really appreciate you guys watching this video. Thank you very much.